Hey folks, thanks for joining me here today. Over the last 4 months, I've been working on an exciting project, a Parkinson's disease detector. There's a website with all the details linked below, but in this video, we'll specifically dive into the technical aspects, focusing on the code and how everything works. Basically, this project uses computer vision to analyze MRI scans and predict whether or not a person has Parkinson's disease. The core technology is YOLO V8 by Ultralyx, an advanced computer vision model. By identifying patterns within MRI scans, the model achieves highly accurate predictions, which we will get to experience in this video. So, why don't we get started? First, since I use Google Colab, the first step is going to be to connect to the GPU. If you're doing this at home, make sure to select the T4 GPU specifically for fastest performance instead of the CPU or the TPU. Now, once connected, I set up a variable called home for easy management of data paths. Next, I finally installed YOLO V8 using the pip command. With YOLO V8 installed, we're going to set our prediction model to YOLO V8N or YOLO V8 Nano, as that is the fastest and lightest model that they offer. Now, for the actual dataset, I access the PPMI, or Parkinson's Progression Markers Initiative database, provided to me by the University of Southern California. After securing access, I annotate the images for training using RoboFlow. Our dataset consists of both control group scans and patient MRI scans at a 50-50 split. Now, since the MRI scans are private, I've had to blur the API key out in the demo, but you can find different public datasets on platforms like Kaggle or GitHub if you want to try something like this yourself. So let's run the import commands. And once that's done, we use the command line interface to set the task for the model to object detection. Then we also say that we want to train the model. And finally, we feed it a pre-trained model as well as the dataset location. Now, to train the model, we will go through 1000 epochs, which means the model iterates through the dataset 1000 times. Now, this is going to take a long while, so why don't we take a break from here? I'll catch you all very soon. Alright, so looks like our training has just finished up. Now, here's where things get exciting. The results include two key statistics, the mean average precision at 50% and the mean average precision at 90%. The mean average precision at 50% indicates how often there was at least a 50% agreement between the predicted output and the actual output. Meanwhile, the mean average precision at 95% measures agreement at a much stricter threshold of 95%. And that's the one we'll be focusing on for this. Now, as you can see here, the model achieved a 98% accuracy overall, with a 96% accuracy for detecting Parkinson's disease and a 99.5% accuracy for detecting the control group. These impressive metrics help confirm the model's reliability and effectiveness. Now, if you'd like to visualize the model, you can run these few commands over here. I've also, here we go. You can render the confusion matrix for this model, and you can see how it trained over time. There's a few other commands I've added that you can test out on your own time if you'd like to. And these are just some quirks to help you visualize the data. Now, before we end off, huge shout out to the University of Southern California for providing me with access to their private MRI scans. Additionally, great thanks to Dr. Simoni for providing me with advice and guidance throughout this project. And thank you for watching. I hope to see you again next time. Cheers.